In this video, we're going to look at using oxidation numbers to determine if a reaction is a redox reaction, and then determining the reducing and oxidizing agents in redox reactions. We're going to look at two reactions now to determine if they are redox reactions and what the oxidizing agent and reducing agent are based on the oxidation numbers if they are redox reactions. So first thing we're going to do for the first reaction is assign oxidation numbers. So we'll start with our hydrogens and oxygens. There's no peroxides or weird compounds here, so we're going to follow our rules of +1 for all of our hydrogens. And -1 or -2 for all of our oxygens. Chlorine in our first compound will have an oxidation number of -1 to counteract the +1 from the hydrogen. In sodium chloride, this is a simple ionic compound, so chlorine is also -1 here, as it has gained 1 electron from our sodium, which will have a charge of +1 here, and sodium as well here will have a charge of +1 in that simple ionic compound. So if we look at our oxidation numbers, we see hydrogen starts at an oxidation number of +1 and ends at an oxidation number of +1. So hydrogen has been neither oxidized nor reduced. Chlorine starts at -1 and ends at -1. So same with chlorine. Sodium, no change in oxidation number, and oxygen, no change in oxidation number. So in this reaction, we see no change in oxidation number for any species, meaning it's not a redox reaction. This is typical for double replacement reactions. If you think back to Science 10, when we learned about double replacement reactions, we learned not to change the charge on the metal ions, and that's because there's no oxidation or reduction taking place in these reactions. We're going to look at our second reaction now, and we'll follow the same pattern. So hydrogen will get +1 where it's in a compound, and 0 where it's elemental. Oxygen is not present in this one. Chlorine will be -1 in this compound and -1 in the simple ionic compound of magnesium chloride as well. And magnesium will be 0 in the reactants because it's elemental, and then +2 in the simple ionic compound here. So in our second reaction, what we can see is that hydrogen goes from an oxidation state of +1 to 0. This implies to us that hydrogen has gained electrons and been reduced. We can also see that magnesium, the oxidation state of magnesium changes from 0 to +2. This change in oxidation number implies that magnesium has undergone oxidation because it has lost electrons. A species that gains electrons and undergoes reduction is an oxidizing agent because it takes those electrons from something else, forcing oxidation. So hydrochloric acid in this reaction is our oxidizing agent. A species that loses electrons and undergoes oxidation is called our reducing agent. So it gives up its electrons to another species to cause that species to undergo reduction. In this reaction, magnesium solid is our reducing agent.